Hello, and welcome to the second part of the basic JavaScript section on freeCodeCamp. In the morning, we started this section and we completed 53 out of 110 challenges. Look at all these challenges completed. And now we're going to complete the last part, which should be also interesting. Welcome everyone who joined in the live stream, and welcome for those who are watching the recording. Make sure that in either case you're following along, so you'll get the most out of this. Alrighty. Okay, let's look on the next challenge. Stand in line. In computer science, a queue is an abstract data structure where items are kept in order. New items can be added at the back of the queue, and old items are taken off from the front. Write the function next in line, which takes an array and a number as arguments, and the number add the number to the end of the array, then remove the first element of the array. The next in line function should then return the element that was removed. Okay, so we're starting to get interesting. It starts to get interesting. So we need to build a queue function. So we have the array and the number. Add the number to the end. So array.push item, this adds it to the end, and then remove the first element. And you also need to return it. So we can use, let's see, pop will pop the last item from the array. And we don't want that, so we want to remove the first one, which will be done with the shift method, right? Item.shift, no, array.shift. Okay, look at that. So we're getting 1, 2, 3, 4, 5 from the initial array, and then we want to pass in 6, and then we have the array. Interesting, they say modify this line to test. Oh, okay, so to test only, but we don't want to test because look at that, working. Hey Ashley, hello Sergio, how are you doing? Alright, understanding boolean values. Another type is boolean. Boolean may have two values, one of two values, true or false. There are basically little on and off switches, where true is on and false is obviously off. These two states are mutually exclusive. Okay. Let's see, note, boolean values are never written with quotes. The string true and false are not booleans. Okay. And they have no special meaning. So we have special, how they're called. Yeah, special keywords for true and false, not inside the string. Alright, let's see. Modify the welcome to boolean function so that it returns true instead of false when the run button is clicked. Okay, so now it returns true. False, we need to return true. And voila, look at that, 50%. Okay, Muffin, hi, Carlos. freeCodeCamp have courses in Portuguese. My vocabulary is low. I have some difficulty to understand. I'm not sure of that. So I can't really tell. Is it only in English? I don't know. Let's see. Maybe we can change it in account, but as far as I know, is only in English. Yep. Well, okay, let's continue. It's just in English, so maybe they will add other languages in the future, or maybe they haven't. I don't know where they are. Okay, using conditional logic with if statements. If statements are used to make the English. All right, let's try again. If statements are used to make decisions in code. The keyword if tells JavaScript to execute the code if the curly braces under no, again. Oh boy, what's wrong with me today? The keyword if tells JavaScript to execute the code in the curly braces under certain conditions, defined in the parentheses. These conditions are known as boolean conditions, and they may be only true or false. Okay, when the conditional value is to true, the program executes the statement inside the curly braces. If it's false, it won't execute. So we have here the syntax. If the condition is true inside these parentheses, then we run this block of code. If it's false, we just skip it. And we have here a function. If the condition is true, we'll return it was true. Otherwise, we'll return it was false. Alrighty. Let's see. Create an if statement inside the function to return yes, that was true. If the parameter was that true is true, and return no, that was false. Okay, true or false. If was that true, we want to return yes, that was true. Otherwise, we want to return no, that was false. Okay, like this. Perfect. Next. Okay, comparison with the equality operator. Okay, we can also test inside the parentheses here if a value equals another value by using the double equals. You need to be careful that the equality operator compares two values and returns true if they're equivalent or false if they're not. Okay, this is also make sure that this is not the assignment, which is only one equals, and also yeah, and it won't check for the data type. So you can do 1 equals 1 like this, which will be true. 1 equals 2 will be false. But look at that. 1 equals 1 in quotes, which is a string, but it's also true because they both ones. So the double equals won't check for the different data types. The triple equals will check for that, and I guess we're going to learn about it in the next challenge. Let's solve this one first. Add the equality operator to the indicated line so that the function will return equal when val is equivalent to 12. So if val is 12, we have equal, otherwise not equal. Comparison with strict equality operator. Yeah, so now we have triple equals, which also checks for the data type. I recommend you always use the triple operator, the strict equality operator, which is a triple equals, because this way you can avoid some mistakes by having different data types. Okay, use a strict equality operator in the if statement when it's equals to 7. Alrighty, next. Okay, practice comparing different values. In the last two challenges, we learned about the equality operator and the strict equality operator. Let's do a quick review. If the values are not the same, the equality operator will perform a type conversion and then evaluates the values. However, the strict equality operator will compare both the data types and the value. Okay. So we have double equals here, which returns true, and triple equals, which will return false, because this is a string and this is a number. In JavaScript, you can determine the type of a variable by using the type of operator. So before your variable, or in this case the 3 number, you can put the type of 3 and it will return number, or type of string 3 and it will return a string. Hello Ivan, welcome to the live stream. The compare equality function in the editor compares two values using the equality operator. Modify the function so that it returns equal only when the values are strictly equal. So we just need to add one more. Okay, so now we have the vice versa operator of the equality operator, which is a exclamation mark and an equal. This is, as I said, the exact opposite of the double equal sign operator. Alright, add the inequality operator like this. One is not equivalent with 99. And also as the strict equality operator, guess what? We have the strict inequality operator. And also, as I said, for the strict equality operator, I highly advise you use this one instead, because it also checks for the type. Okay, the exercise says we need to check if it's different than 17. Okay, greater than operator. This is as in math. Checks, see if the number is greater than. But look at this. It also evaluates the true. Alright, because it will convert data types of values while comparing. Add the greater than operator to indicate lines so that the return statement makes sense. If val return over 100, then if val over 10, return 10 or under. Okay, so here we check this one if it's over 100, over 10, and otherwise it's 10 or below. Okay. Comparison with the greater than or equal to operator. So by adding an equal to the greater signs, the sign, you can also check if the number is greater or equal to that number. Alright, let's see. 20 or over, greater than equals to 20, 10 or over, so greater than equals to 10, and less than 10. Comparison with the less than operator. Alright, this becomes under 25, under 55, and 55 and over. So is the other operator. And I guess we have, yeah, less than or equal to. Less than or equals to 12, less than or equals to 24. I'm going through this quickly. Oh, less than equal. Because, well, it's pretty. Okay, comparison with the logical AND operator. Alright, so look at that. Now we have something new, the logical AND operator. Okay, let me drink a little water and we're going to go straight. Alright, so sometimes you need to test more than one thing at a time. So in this example, we want to check if the number is greater than 5, but at the same time is less than 10. So instead of having two if conditions, like an inner if, we can use the AND operator, the logical AND operator, which is a double, what's that sign? I forgot how it's called. The AND, right? Hello Ankit, welcome to the live stream. So we can then put this condition on one line. It will read like if the number is greater than 5 and the number is less than 10. Okay, change code below this line. We want to replace the two if statements with one statement. So let's remove this statement like this, and then using the AND operator between the conditions, which will return yes if val is less than or equals to 50 and greater than or equals to 25. Okay, and because it's more obvious that it needs to be between 25 and 50, let's put this as the first one. So now this evaluate says if the value is greater or equals to 25 and is less than or equals to 50. Alright. Run the tests. 60%, good. We're doing pretty good. Comparison with the logical OR operator. So as we have the logical AND operator, we have the logical OR. So basically in this condition, we only want one of the sides to return true. So it's either this one true or this one. So is the number greater than 10, or if it's less than 5, it will be true. Otherwise it won't be. Alright, let's see. Combine the two if statements like this into one statement which returns outside if val is not between 10 and 20 inclusive. Okay, so val is less than equals to 10 and val is greater than 20. I guess, right? If val is not between. Oh, okay. Should return outside. Oh, and this should be OR. Sorry. Yeah, not AND, OR. Okay, and apparently we need to avoid 10 and 20. So we can just remove the equal. Alright, so this will say if it's less than 10 or if it's greater than 20. Let's see. Alright, good. Introducing else statements, which is pretty obvious, I'd say. So we can check if the number is greater than 10, we do something, else we do something else. Isn't that logical? It's not, I don't know what is. Combine the if statements into a single if-else statement. So yeah, instead of having multiple if statements, we can just remove this and say else. So basically this will say if greater than 5, return, we going to store inside the result variable bigger than 5. Else we're going to store 5 or smaller. Introducing if-else statements. Alright, so what if you want multiple checks? Then we can use the else if. So this reads the following way. If number is greater than 15, run this code. Else if number is less than 5, run this code. Then if neither of them are true, it will default to the third one, which is the else. So the number is between 5 and 15. Okay, convert the logic to use else if statement. If val is greater than 10, else if val is less than 5, else we have this condition. Well, in this case, we could have just have the return here. It's basically the same thing. So if we'll check this one, then it will check this one, and both of them are false, it will go here and return. But I guess they want the third else. So let's just wrap this code inside the else statement. Okay, run the code and voila. Logical OR in if-else statements. Okay, let's see. Alright, so logical OR, order, not OR. Oh, alright. Yeah, so we need to be careful of what statement comes first. Because, as you can see in this example, if we check if x is less than 1, it will return less than 1, but it's also less than 2. So what are we doing then? We are skipping we are okay, let's see. Less than 1, less than 2. Yeah, so when we pass while this function look the same, if we pass a number to both, we get different outputs. So for 0, look at that, it will get less than 1, and for 0 it will get less than 2, which is not very logical. I mean, it is, but we are skipping the order. The order is not very logical. So let's see. Change the order logic in the function so that it will return the correct statement in all cases. Less than 10, less than 5, greater than or equal to 10. Let's see, if we run now, it will get should return less than 5. Okay. But it's also less than 10, so that's not entirely wrong. But we don't want to say less than 10, we want to say less than 5. So let's just remove this from here and put it here. So we swapped the two, the first one with the second one. And we passed. Okay, chaining if-else statements. If-else statements can be chained together for complex logic. Here is pseudocode of multiple chained if-else statements. If, else if, else if, else. Alright. So we can have a bunch of them. Write chained if, else if statements to fulfill the following condition. That's if number less than 5. Return tiny. Else if number less than 10, return small. Else if number less than 15, return medium. Else if number less than 20, return large. And else, because that's the last one, we want to return huge. Alright. This will be the default case. Good. Golf code. Alright, let's see. This will be interesting. In the game of golf, each hole has a par, meaning the average number of strokes a golfer is expected to make in order to sink the ball in a hole to complete the play. Depending on how far above or below par your strokes are, there is a different nickname. your function will be passed par and strokes arguments. Return the correct string according to this table, which lists the strokes in order of priority, top and bottom, lowest and highest. Par and strokes will always be numeric and positive. We have added an array of all the names for your convenience. Okay. Strokes 1, par minus 2, par minus 1. But what's par? Oh. Okay, so we have the par here, and then we have the strokes. Okay. Good. Let's see. We need to combine an if else if. So we need to chain them. Yeah. If stroke, those are strokes. Okay, yeah, strokes is equal to 1. We want to return all in 1. That like that. Okay, else if we have par minus strokes, right? No, par minus 2 or less than. I hope I'm doing this right. Let's see. Strokes. So par minus 2 strokes are less than equals par minus 2, which is the first argument. Then we return eagle. Else if strokes par minus 1, we return birdie. Else if strokes not less than, it equals. If strokes equals, let's use triple equals because that's better, par, then we want to return par. Else if strokes equals par plus 1, we want to return buggy. Else if strokes, not storkis. Okay. Par plus 2, return, let's see, double buggy. Else we want to return go home because this is less than greater than equals to 3. So if we did everything correctly, hopefully we get it right. Let's see. Alright, look at that. Perfect. Selecting from many options with switch statements. Okay, so if you have many options to choose from, use a switch statement. This is basically like a combined if and else if statement. I don't use switch that much, but it's useful when you have a lot of if, that, then that, if, a lot of ifs and else if statements. Then it's more logical to use the switch. Alright, 1 second. Alright, a switch statement tests a value and can have many case statements, which define various possible values. Statements are executed from the first match case until we have a break. Alright, here's an example. So we have the switch and we have our case, which is going to be tested. And then the first case if the lowercase letter is A. In this case, we can test for anything, number or equality or whatever. If the lowercase letter is A, then we apparently here we're cancelling log the uppercase A letter, and we're breaking out from this switch statement, because if you're not using break, it might go to the second case, and we don't want that. Okay, case values are tested with the strict equality. Alright, good to know. I didn't know this actually. The break tests JavaScript to stop executing statements. If the break is omitted, the next statement will be executed. Alright, write a switch statement which takes val and sets answer for the following conditions. Alright, let's do it. Switch val, we want case 1, and here we want to say answer to be alpha. I want to break also, and let's copy this 3 times, 2, 3, 4, and we want beta, gamma, and delta. Alright, I think that's it. Yep. Adding a default option in switch. Yeah, so you can add, like we had the if, else, if, and the else, so that the last one, the else, you can have the same in switch, the default, which will be obviously the default case if none of the conditions above are fulfilled. Write a switch statement to set the answer to the following conditions. Okay, switch val again, case A, we want answer to be apple. Oops, and we want to break. Don't forget the break. Now we want to paste it 2 more times. Let's paste it 3 more times. And this will be case B, and this will be C. Word and cat, and this will become the default, where the answer will be stuff. And we're breaking, although on the default case, if it's the last one, we don't really need to break, but yeah. So this will basically test, is it A, then do this, is it B, then do this, is it C, then do this. If it's neither of them, then go to the default. Alright. Multiple identical options in switch case, switch statements. So yeah, as you can see here, we have case 1, 2, and 3. And in this case, even if it's 1, so if it's 1, it will go here also, because we didn't close it, we didn't break out of the switch statement. So if it's 1, 2, or 3, we'll run this code. And case 4 will be this one. Alright. Write a switch statement to set answer for the following ranges. Alright, this will be a little to type. So val. Like this, we want case 1, case 2, case 3. To be answer, oops, low. Alright, we can copy this. 1, 2, that, and 4, 5, 6, 7, 8, mid, and high. And also we don't need to forget to add the break. And let's add it here, although it's not that required. Good. Replacing Ifelse chains with switch. Alright, so this is where you want to use switch, because if else becomes a little bit of a mess. See, if switch looks much better. Case 1, case 2, and default. while the if else it's a little cluttered. So let's see, change the chained if else statement into a switch. Alright, so we want to switch for the value, and we wrap it around here. Okay, and we have cases when, let's see, case Bob. When case Bob, we want the answer to be Marley, and we want to break. Okay, we have case 42, and we want to break. Then we have case 1, break, case 99, break, whoops, and this is the default, right? No, else if val, no, it's default. So we just case 7, break, like that. So now we change the if and else if statements into a switch, and in my opinion it looks a little more cleaner. Alright, you may recall from comparison with the equality operator that all comparison operators return a true or false. Sometimes people use an if-else statements to do a comparison like this. But there's a better way to do this. Since triple equals return true or false, we can return result of the comparison. Yeah, this is an interesting trick. So instead of doing if A equals to B, then return true, else return false, we can just use the fact that the strict equality operator, it will also return if it's true or false. So we just have to, it will say if it's true or false, so we just need to return that comparison. Alright, this also works for greater or less, or greater and less, and all of those. Fix the function is less to remove the if else statement. Okay, so we can just say return A less than B, which is the same as this. Let's see, will it allow? No, you should not use an if else. It's weird because it's commented, but let's see, if I put it here, maybe it will allow us to have the example. No, that's weird. This might be a bug in their system. So if you're watching and working on the freeCodeCamp platform, please fix this. Alright, return early pattern for functions. While a return statement is reached, when a return statement is reached, the execution of the current function stops and control returns to the calling location. Okay, the above outputs, yeah, you can see here we have a console log hello, then we return word, and then we console log bye bye. But this won't run because we are returning out of the function. When you have the return keyword inside the function, it will stop the function from running, and it will return out of it, sort of. Okay, modify the function a/b test so that if a and or b are less than 0, a less than b or a less than 0 or b less than 0, the function will immediately exit with the value of undefined. So we can say return undefined here, or we can just do return, which will basically return undefined. Okay, so basically in this function we're checking to see if a and b is less than 0. If it is, we don't want to continue, so we're breaking out. Alright, let me know in the chat if anytime you have any questions. Okay, so here is interesting problem. In the casino game Blackjack, a player can gain an advantage over the house by keeping track of the relative number of high and low cards remaining in the deck. This is called card counting. Okay, sorry there, I had to I don't know how you call it in English. I did like achoo. Okay, sorry about it. Alright, let's move on. Having more high cards remaining in the deck favors the player. Each card is assigned a value according to the table below. When the count is positive, the player should bet high. Okay, when the count is 0 or negative, the player should bet low. Look at this. We'll need to create a card counting function. Which will receive a card parameter, which can be a number or a string, and increment or decrement the global count variable according to the card's value. See table. The function will then return a string with the current count and the string bet if the count is positive, or hold if the count is negative or 0. The current count and the player's decisions bet or hold should be separated by a single space. Alright, for example, output -3 hold, 5 bet. Okay, hint. Do not reset count to 0 when value is 7, 8 or 9. Do not return an array. Do not include quotes, single or double, in the output. Okay, so this will be an interesting challenge. Okay, so let's do a switch statement, right? We have the card, so we want to switch the card. And in case that, let's see, case, we can do all the cases, although not necessarily required, but let's do 3, 4, 5, 5 like this, and 6. We want to increase the count plus, and we want to break also. Also we have case 7, case 8 and case 9, where we basically don't do anything. So we don't really need to do anything here. Let's comment it out. And we have case 10, case J, J like that, and let me copy J, Q, K, and A, which will decrement the count. And I think that's all. Let's see. The current count of the player, which is okay. The function will return a string with the current count and the string bet if the count is positive, or hold if the count is negative or 0. Okay, change me. So we want to return. Let's see. We need to construct a string. So answer var answer will be count plus we need to keep track if the count is less than equals to 0 or it's greater than. So let's do a check here. If count is less than or equal to 0, then we want, let's see, what should this be called? Var bet or hold. This is first name variable, but I have no idea. We call it bet or hold should be hold, and otherwise it should be bet or hold should be bet, like that. So now we can construct our answer to be count plus a space and plus bet or hold. And we want to return our answer. Okay, let's see. Is it working? Look at that, it is. And we also don't need this, so let's clean it up a little bit. Maybe we can add the space here so we can return this. Or maybe even better, we can do answer. Nah, that's fine. Better hold, then we keep track of the count here. Alright. Or we can also return this instead of storing it into an array. Yeah, we just different possibilities. Run and test. Good. Build JavaScript objects. Ooh, this is big. This is a big topic. JavaScript objects. You may have heard the term object before. Objects are similar to arrays, except that instead of using indexes to access and modify their data, if you remember from the previous live stream, we learned about arrays, and the way we could access the data, we had to pass in the index. We can now access the data in objects through what are called properties. Objects are useful for storing data in a structured way. And can represent real-world objects like a cat. Here's a cat object. Objects are declared with the curly braces, and inside you can see that we have property and value pairs. Property goes on the left side of the column, is this called, I guess? Let me know if I'm wrong. And on the right side we have the value. So here we have the name Whiskers, the legs 4, it has 1 tail, and it has 2 enemies, which is also an array. So you can see you can set the properties to pretty much any value you want. We have string, numbers, and an array. And you can even have an object inside an object, and all sorts of interesting things. You can store booleans or stuff like that. Okay. You can see that here we have the properties as strings, but you can also use numbers as properties. You can even omit the quotes for single word string properties as follows. Yeah, usually this is what you'll do without quotes. The property name. This needs to be inside quotes because it's a string. You can also store it inside numbers. I mean, having the number as a property, which is not used, and you shouldn't use it, but yeah, it's possible. And then what we had here is string as a property name. However, if your object has any non-string properties, JavaScript will automatically typecast them as strings. Okay. Let's say make an object that represents a dog called my dog. So we have here an object declaration, and we're going to say that the name a string. Okay. We want it to be called my make an object that represents a dog which contains the property names, legs, tails, and friends. You can set these objects property to whatever values you want. Okay, so dog. I don't know. Jim. That's a funny name for a dog. Legs we want 4. Tails we want 2 because it's a fancy dog with 2 tails. And friends, an array. Let's see. Camper and Florin. So the camper, our dog, their dog, and also I'm his friend. Now look at that. We have 4 properties: name, legs, tails, and friends, with 4 values: strings, numbers, string numbers, and also arrays. Alright, accessing objects properties with dot notation. Remember, in arrays we needed to use the brackets and pass in the index. Well, objects you can get the property of an object by using the dot notation. So we have my object, the name of your object, dot, and what property you want to access. Okay, read in the property values of test object using dot notation. See the variable hat value, set the value hat again. Hello Pascal, welcome to the live stream. Set the variable hat value equal to the object's property hat. Okay, test object dot hat. You can see that we don't need to put quotes. It will know that this will go here and it will take this value. Shirt value equals to shirt. That shirt. So now if you're going to console.log hat value and console.log shirt value, you can see that it's bell cap and jersey. Alright. Accessing objects properties with bracket notation. Okay, so we can also use bracket notations as we have in JavaScript in arrays, but it's not that common. A couple of reasons why you would use this. So as we did in for the arrays, we use brackets, and inside here we pass the number, which was the index of the array. But in this case you can see that we're passing the property name inside as a string. And the reason we do this is because this property name, as you can see here, has a space. So we can't do something like my object that space name. This is not valid. So this is why we need to put it inside brackets and as a string. So now it will know. And this is one reason why would you use this, although I highly recommend you don't have property names like space name with a space here. Instead of using space name, just use name. Just make sure you use something like space name, like this. So camel case, as we learned before. Alright, and another reason, if you have a variable, there are scenarios when you want to access the object's properties using a variable. So you'll pass in inside the brackets here. But probably we'll have an example in the future. Let's see, read the values. Let me delete this. Read the values of the properties, an entry and the drink. Okay, so an entry, and here we want the drink. Okay, so because we had spaces, we needed to put them like this. I hope this is clear for you. Alright, let's see, 75%. Good, we're almost, no, not here really, but we're 3/4 away, right? Yeah. Accessing object properties with variables. Okay, so exactly what I said, you might want to do this. We have this example where we have an object with 3 properties with 3 values, and we are storing the inside my dog the hunter string, and we can get the value of the hunter property by passing the variable inside the brackets here. Dogs, my dog, which is hunter. So basically we pass in a string but inside a variable, and this can be changed. So in the future you might want to get my breed for something else. Let me copy this so I can change it and show you. So instead the hunter, we might want to get the Snoopy. So we're passing the Snoopy here. Well, it's easier if we did something like this. So dogs that Snoopy. But this value, you might have some conditions to create it. Who knows, maybe you get it from a server, maybe you don't know it exactly what it is. So this is why dynamically you're able to pass in a variable inside the brackets to get the property. Okay. Okay, another way you can use this concept is when the property's name is collected dynamically during the program execution as follows. So we have an object, okay, and then prop prefix. We set the s to be prop and we append the string, okay, and some prop will be prop prefix name. Some prop now holds the value prop name. Console.log some prop prop name. Yeah, as you can see here, we are creating dynamically on the fly the property name. So yeah, this is a scenario where you might want to use a variable inside the bracket. Note that we do not use quotes around the variable name when using it to access the property, because we are not using the value of the variable. Not because we are using the value of the variable, not the name. Okay, I highly suggest you play around with this and see how it works, and then you can understand it better. Use the player number variable to look up player 16 in test object using bracket notation. Then assign that name to the player's variable. Okay, player number will be 16 and we want player number like this. Updating object properties. Alright. We might want to change a property. So the way you can do that is by saying by accessing the property and saying it equals to something new. Basically, this is how you get it on the first place, but if you want to set it, you just equals it to something else. Also, you can do it by the brackets notation. If you remember, this is what we did for the arrays also. By saying array of index 1, we getting it, and by giving it equals to something, we're setting that value. Okay, update the my dog object's name property. So my dog, that name, we want to update it. Let's change her name from Coder to Happy Coder. Happy Coder. Alright. Add new properties to a JavaScript object. You can add new properties to existing JavaScript objects the same way you would modify them. Here's how we would add a bark property to our dog. Alright, so even if the property doesn't exist, you can see in this example we don't have the bark property, we only have name, legs, tails, and friends. We can add it just simply by assigning it a value. Let's see, we want to add the bark property, so my dog dot bark, and want to set it to woof, like that. Good. Let's see console.log my dog before and after we assigning it. Okay, look at that. So before we had an object with 4 properties, name, legs, tails, and friends. Then we assigned the bark property to be woof, and look at that, it's added here at the end. Alright, hope that makes sense. Delete properties from a JavaScript object. You can delete it by using the keyword delete. before and selecting which value you want, which property you want to delete. Alright, so let's delete the tails property. Delete my dog.tails. Okay, let's console it again so we can see how it works. If it works. Okay. So first you can see we have the tails in the object, but then we don't have it, it's deleted. Okay, next, using objects for lookups. Alright, objects can be thought as a key value storage, like a dictionary. If you have tabular data, you can use an object to look up values rather than a switch statement or an if-else chain. This is most useful when you know that your input data is limited to a certain range. Here's an example of a single reversed alphabet lookup. Okay, so we have the alphabet 1, 2, 3, 4, and we have the alphabet reversed. And we can get the data by using a bracket. Here we're using a bracket because it's a number, so you can do alpha.2. If you have a number, you want to put it inside the bracket. Okay. Convert the switch statement into an object called lookup. Use it to look up val and assign the associated string to the result variable. Okay, so let's see. Instead of a switch, we want to var lookup, and we want to create an object. Okay, we have case alpha, and the result will be Adams. And we have the comma. We have Bravo, Boston. We have Charlie, which will be that. Okay. Delta Denver. Echo will be easy. And Foxtrot will be Frank. Like that. And we can also go ahead and remove the quotes here around the property. Oops, like that. Perfect. And now we can just do lookup. Instead of returning result, we want to return lookup by val. So we don't really need result. Or we could have kept result here, and we can set it here. Result to be lookup of val. Alright, and look at that. In this example, we're passing Charlie. It will go here. It will go here, and it will say lookup of Charlie, and it will get. It will be Chicago. Okay. And it will be stored in the result, and we're returning the result. Testing objects for properties. Okay, this is a nice function. We can use the .hasOwn property function, and we can pass in a property name, and it will check if that property is inside the given object. So basically, this reads as if my object has the property top. If it has it, then it will return true. Otherwise, it will be false. Okay, modify the function to test my object for check prop. Okay, check prop. Turn change me. Alright. So we want to do my object has own property, and we can pass in the check prop like that. So it will check if this object has this property name. Okay, should return pointing. Oh, if the property is found, return the property value. Okay, 2. So we want to check, and if it has it, then we want to return it. So if this, remember this returns true or false, then we want to return my object of that check property, right? So if it has a property, then we want to return it. Otherwise, we want to return not found. Not found. Alright. I didn't read this part, so yep. Make sure you read everything. Manipulating complex objects. Ooh, sometimes you may want to store in a flexible data structure. JavaScript Object is one way to handle flexible data. They allow for arbitrary combination of strings, numbers, booleans, array function, and objects. Here's an example of a complex data structure. We have an array of objects: artist, title, release year, formats, and gold. This is an array which contains one object inside. The object has various pieces of metadata about an album. Okay. Good. We're talking about JSON here also, which is a related data interchange format used to store data. Okay, more of that later. You will need to place a comma after every object in the array, unless it is the last object in the array. Okay. Good. Let's see. Add a new album to the My Music array. Add artist, title, strings, release year, and the formats array of strings. Alright, so we can see here we have this array which has, as of now, one object with all of this data. And we need to add another object. So let's add in a comma here. And inside here we can do add object. Let's just copy this because it has all the data we need. Artist, title, release year, formats, and also it has gold. We don't need this. Awesome. Accessing nested objects. The subproperty of the object can be accessed by chaining together the dot or bracket notation. So if we want to get the glove box here, we're going to say my storage dot car dot inside, and then we have a bracket with this value because it's a string and it has a space. Yeah, cabinet, top drawer, folder 2. Okay, access the my storage object and assign the contents of the glove box property to the glove box contents value. Okay, so we want my storage, a car inside, and here we want the glove box, like that. And we store it inside this value. So you can see how we chained all of these property names. Perfect. Accessing nested arrays. Okay. Yeah, we can use nested objects, and we can have nested arrays also. And we access it with the index. I think we did something like this before, didn't we? So basically this goes our pets, the first array, the first item in the array, and then names, and the second one. Because keep in mind it's 0 index, so we're starting with 0. Retrieve the second tree from the variable myPlants using object dot and array bracket notation. Okay, and we're going to assign it here. So myPlants, and we want the second tree, so 1 to 2. Okay, return the tree from the variable myPlants using the second tree. But this is it, right? Second tree should be fine. So return the second tree from the variable myPlants using the object dot and array bracket notation. Oh, second tree, look at that, we have types, trees and flowers. Alright, so we want myPlants of 1, and then we have list of 1 also. So basically the second object and the second string here. Fine. All right. Record collection. Whoa, look at that. How much text. Let me go over quickly. Okay, write the function takes the ID, the property for tracks, and the value to modify the data in this collection. If property with text and value isn't empty, update or set the value for that record. Oh boy, this is a big one. We have a collection of musical album collection, and each album has several properties with an unique ID as a key. Alright, write the function which takes an album's ID, a property, and a value to modify the data in this collection. Okay, if property isn't tracks and value isn't empty, update or set the value for that record album's property. Okay, so let's do them step by step. If the prop different than tracks and value isn't empty, so it's different than empty string, then we want to set the value for that record albums. Okay, so we need to take the collection of this ID and its value. Probably set the value for that record album's property. Okay, and this album will have the value. Does this make sense for you? So we're targeting the collection ID, so the album, the record. And first we're checking if it doesn't have a track property, right? So if prop isn't tracks, okay. And the value isn't empty, so this, the prop and the value were given. Update or set the value for that record properties album. Okay, so we go inside, we're getting the ID and we're setting the album to that value. Your function must always return the entire collection object. Okay, so it returns it. There are several rules for handling incomplete data. If prop is tracks, but the album doesn't have a tracks property, create an empty array before adding the new value to the album's corresponding property. Hello, Jordi, welcome. So let's read it again. If property is tracks, so if prop is tracks, but the album doesn't have a tracks property, okay. So if collection ID album has own property, no. So this collection, but the album doesn't have a tracks property. So has own property tracks. So it doesn't have. So we put exclamation mark there because it doesn't have it. Create an empty array before adding the new value to the array album's corresponding property. Okay, so collection of ID, tracks will be empty array. So basically we're checking if the prop is tracks, and if we don't have a tracks array, if we don't, then we create it and we set it to an empty array. If prop is tracks and value isn't empty, okay, so if prop is tracks and value isn't empty, push the value onto the end of the album's existing tracks array. So we take this and we want to push the value. Alright. If value is empty, delete the given property from the album. Okay. If value is empty string, delete the given prop. So collection, ID, and prop, we want to delete it. Alright, so we did a lot of stuff. Let's see, does it pass? Okay, let's console.log collection for and after. Let's see. So we pass in the ID and the artist. So the prop is different than tracks and the value is not empty. Collection.id album should be the value. But if we're running the test, artist should be. Okay. So here we don't want to set the album. We want to set the property to this value. Alright. So a lot of stuff going on here. Maybe you should go over again to all the description and read it carefully, and then just do it step by step. So we have 1, 2, 3, 4 conditions, and we did what they asked us to do. It's weird that we only have one test, but yeah. Anyways, let's move on to the next one. Iterate with JavaScript while loops. Alright, we're going to loops now. You can run the same code multiple times by using a loop. The first type of loop we'll learn is called a while loop, because it runs while a specified condition is true and stops once that condition is no longer true. Okay, so we have here an array, an empty array, and a variable I set to 0. While I is less than 5, which is it in the first loop, we want to push inside the array the value of the I variable. And then we want to increment the I. And it will do this 5 times. Okay, Jordi, could you check the solution from freeCodeCamp and explain at the previous assignment? Well, I did explain it while I was creating it, so maybe you should just go back and look over again. Alright, in the code above, while loop will execute 5 times. Also, make sure that inside the while loop, you are changing the condition somehow, because if you're not changing the condition, it will run an infinite number of times and it will block your browser. That's called an infinite loop, and you don't want that. So always there's a rule, sort of, that you want to change the condition of the while loop. Well, maybe you want to have an infinite loop for a while if you're creating a game and you want to have your loop for the game. But other than that, I don't really see why you want to have an infinite loop. Okay, in the code example above, oh, I read this already. Add the numbers 5 through 0 in descending order to my array using a while loop. Alright, so this will be fun. So we want to add the numbers from 5. Let's store it inside the variable I, which will be 5. And then while I is greater than 0, we want to do something. We want to push it inside the my array I. But at the same time, look at this. So we didn't change the I. So basically what this will do, it will go like this. While I is greater than 0. Is I greater than 0? Sure. We want to push it. Okay. Then it goes again. Is I greater than 0? Sure. And it will push again. So this is why it will go an infinite number of times. And we have here potential infinite loop detected on line 6. Test may fail if this is not changed. So what we want to do now is change the I minus minus. So first I will be 5, then 4, 3, 2, 1, and 0. Through 0 inclusive. So we also want to add 0. That's why we're going to change this to greater than equals to 0. Alright. Good, it works. Iterate with JavaScript for loops. Alright. We have while loops and we also have for loops. The difference between them is that in the for loop you can specify the starting, the initialization, the condition in the final expression, like we have here. Look at that, separated by semicolons. We first have a starting condition, an initialization. This will run one time before the loop starts. Then it will have this condition. This will run every time before every loop. So if it will check, is I less than 5? Sure, first time it is because it's 0. And then finally we have the final expression, which will run at the end of the for loop. So basically this is somehow of an advanced while loop because you don't have to initialize. I mean, you do everything here in this block of code. Okay, let's see what else do they say here. Yeah, final expression is executed at the end of each loop. Alright, make yourself very comfortable using a for loop because you might use it a lot. Okay, and the same with the while loop we had in the previous example. This will start with 0, it will increment every time, and it will push to the array. So keep in mind that this will run only once before starting the loops. This check will run every time at the beginning of the loop, and this will run every time at the end of the loop. And basically what you have here will run in between. Okay, use a for loop to work to push the values 1 through 5 onto my array. Okay, for var I equals 0, I less than 5, no, I equals 1, and I less than 6, we can do that, or we can say I less than equals to 5, and I plus plus. Okay, and we want to do my array that push I. So it will first be 1, then it will push inside the array, it will increment. Then it will be 2, it checks if it's less than 5, and it will push, and so on and so forth. iterate odd numbers with a for loop. Okay, look at that. So now we have a for loop, but here at the final execution part, we have, instead of I++, we have I plus equals 2. So it will go 2 steps, basically. Okay, so instead of having all the numbers from 0 to 10, now we have all the odd numbers from 0 to 10. 0, 2, 4, 6, and 8. And 10, we don't have 10 because it goes up to 10. So the 9 will be the last one if it will be to check. Well, actually it will be 8 because we're going just the odd numbers. Alright. Let's change our initialization so we can count by odd numbers. Alright. Push the odd numbers from 1 through 9 to my array using a for loop. Okay, for var I equals to 1, I less than equals to 9, so we want to go up to 9, I plus equals to 2. My array that push I. So this will push 1, 3, 5, 7, and 9. Alright. Count backwards with the for loop. Okay. We can do a backwards count by changing the initialization with the high value, so 10, and then instead of having I less than 10, we can say I greater than 0, so we're just going the other way around. And here, instead of having I minus minus, or I plus plus, or I plus equals 2, we have I minus 2. So we're going the other way around, which is also good. Our array will now contain 10, 8, 6, 4, and 2, because we go the other way around. Good. Push the odd numbers from 9 to 1. So basically we do I equals to 9, I greater than 1, greater than equals because we want to add 1, 2, I minus equals 2. My array that push I. And voila. Iterate through an array with a for loop. Alright, yeah, this is mostly why an array is used. I mean, most of the times. You want to loop over an array and get all the values, or do something with all the values. The way we can do this is to use I as the index of the array. We start with 0 and then we go up to the array.length. Remember this property we had on the arrays, which will return us the length of the array. So we want to go up to length, and then we increment by 1. And then here inside the console log we can return the value of the array at that index. First we return the first one, the second one, and so on and so forth. So remember that is 0-based indexing, so it will start with 0. Okay, declare and initialize a variable total with 0. Var total will be 0. Use a for loop to add the value of each element of my array to the total. So for var I equals 0, I less than my array dot length I plus plus. And here we're going to do total plus equals my array of I. My array like that. Let's console.log total. And look at that, how easy it was to add up all these numbers. So instead of saying something like total plus equals my array of 0, then total plus equals my array of 1, then total plus equals my array of 2, well, total here, we can just remove this and use a for loop instead, which is great. Also, the for loop knows, in this case we know the length, so we can use that in our advantage, because we might change the array. We can add 8 and 10 and 30. So look at that, it will change, it will be dynamic. So we don't have to change anything now inside the for loop. Okay, let's remove this because it needs to be equal to 20. Alright. Hello Ivan, welcome to the live stream. Nesting for loops. Alright, so this is fun. I've learned this the hard way in college. But hopefully you're going to learn it easier than I did. Alright, let's say that we have a multi-dimensional array. We can use the same logic as the prior waypoint to loop through both the arrays and the subarrays. Here we have an example. We have an array, and inside it we have multiple arrays. So it's multi-dimensional array. And we can do an inner loop. So we have the first loop, which goes from I0 to I less than array.length, and then we are using then we are using j to go from 0 to the array, the first item, or well, the array at index I dot length, and we're incrementing also. Then we're going to access all the elements inside this multi-dimensional array. Okay. Yep. Modify function multiply all so that it multiplies the product variable by each number in the subarrays of R. Okay, so we're starting with 1. Then we want the first loop var I equals 0, I less than array.length I plus plus. And then in the inner loop, we want to do var j equals 0, so we want another variable, we can't use I again. J less than array of I, that length, so the inner array, j plus plus. And here we can say product time equals, we learned about this in the previous live stream, to array of I and j. So we're going inside the array I, so the first dimension, and then we're getting the next inside it, so inner array or subarray or whatever you want to call it. And we can console.log this so we can see what we get. Look at that, 5040. So 1 times 2 times 3 times 4 times 6, 7, and 5. This will give us that. Let's see, is that right? Console.log. 1 times 2 times 3 times 4 times 5 times 6 times 7. Look at that. How nice. But we did everything with subarrays, multi-dimensional arrays. Alright. Next, iterate with JavaScript. Do while. Okay. So we learned about the while loop. We learned about the for loop, and we also have the do while loop, which is different than the while loop because no matter if the condition is true or false, it will run the block of code at least once. So it will go like this: do this, and then it will check if I less than 5. Okay, if it is, then run it again. But it will run at least once, no matter what. Alright, let's see, what else do they say here? Okay. Okay, so yeah, is different from other loops is in how it behaves when the condition fails on the first check. Alright, yeah, so that's the difference. I have no idea what they say here. I guess that's all. We don't really use do while that much. At least I don't, so yeah. Change the while loop in the code to a do while loop. So the loop will push only the number 10 to my array. Alright, so do while. Okay, let's copy this, put it here. Push I. Yeah, so yeah, that's pretty much it, because you can see that the I initially is 10. It will go here, it will push I, it will increment it, and then it will check if I is less than 5. And obviously now it's 11, so it won't run. Alrighty. Replace loops using recursion. Ooh, nice. This is a fun topic. Recursion is the concept that a function can be expressed in terms of itself. To help understand this, start by thinking about the following task. Multiply the first n elements of an array to create the product of those elements. Using a for loop, you can do this. So we have the product, we are looping over the array. Here you can see that here they used n as the length of the array. And then we multiply the product with the value of the array at the current index. And then we return the product. However, notice that multiply array n equals of multiply array n minus 1 times array n minus 1. So yeah, that means you can rewrite multiply in terms of itself and never need to use a loop. Alrighty. Let's see. We have the function multiply here, which will basically call itself with n minus 1. And it will do so until we have a default condition or breakout condition. We need this when n is less or equals to 1. If we didn't have this condition, it will run an infinite number of times, and that's not what we want. The recursive version of multiply breaks down like this. In the base case, yeah, so this is the base case. Where n less than equals to 0, it returns 1. For larger values than of n, it calls itself, but with n minus 1. So it keeps going minus 1, then minus 2, then minus 3, and so on and so forth. That function call is evaluated in the same way, calling multiply again until n is less or equals to 0. At this point, all the functions can return and the original multiply returns the answer. Okay, that's a little confusing what they say here. Right, recursive function must have a base case when they return without calling the function again. In this example, when n is less or equals to 0. Otherwise, they can never finish executing. Yeah, keep that in mind. If you ever want to have a recursive function, you need the base case. So what's the base case? This is how you're going to start creating the recursive function. Alright, write a recursive function sum array n that returns the sum of the first n elements of an array. Alright, first we're going to have the base case. If n less than equals to 0. Right? Array that returns the sum of the first n elements of an array. Okay, yeah. I guess at this time, think of this n like the reversed for loop. Remember when it did for I equals 10 and I greater than 0. So we did a reversed for loop. Okay, if it is, then we're going to return return the sum of the first n elements of an array. We want to return 0, right? Because we don't want to add anything. Else, we want to return sum of array n minus 1 plus array of n minus 1. So we're going backwards. array n minus 1 will be the last element of the array, and we adding the second to last element, because now n will be n minus 1, and here array n minus 1 will be basically n minus 1 minus 1, so n minus 2. And the base case is n less than equals to 0. Okay, so this should work. Perfect, look at that. We have a couple of more problems. Let's see. Profile lookup. We have an array of objects representing different people in our contact list. Okay, look at that. We have numbers, names, and likes. A lookup profile function takes the name and the property as arguments has been pre-written for you. Okay. Alright. If the function should check if name is an actual contact's first name, and the given property, prop, is a property of that contact. So if name is an actual contact's first name, alright, and the given property is a property of that contact. Alright, so we basically have to loop over all of the objects here. If name does not correspond to any context, then return no such contact. If prop does not correspond to any valid properties of a contact found to match name, then return no such property. Ooh, okay, so let's see. We want to loop over all the elements from the array. So for var is I less than, let's see, contacts, this is our array name, contacts dot length, and I plus plus. Right. Okay, what now? We need to check if the current, let's store it in a variable, current contact will be contacts of I, or maybe just say contact, so we store it and don't have to say contacts of I every time. If contact dot name equals to name. Oh, now we need to check the first name. The function should check if name is an actual contact's first name. Okay, so contacts dot first name is equals to name. Then we need to check if it has the property. So if contact prop is something. It has this property. So has own property prop. If it has, then we want to do what? The value of that property. Then we want to return contact of property. Right? So we have the first name be that name, and we have the contact having that property prop. In this case, we want to return that property value. So we do contact.prop, contact prop inside the brackets here. If it doesn't have it, we want to return no such property, because we found the contact with the first name, but it doesn't have the property, so we return it. Alright, then we have one more condition. If it loops over all of them, all of the contacts, and we can find the property, the contact, we want to return no such contact. One thing with the for loop, let's end here to see that it's inside this function. So basically, when you have a return statement inside of a for loop, and because this for loop is inside of a function, this will basically also stop the for loop of running. So it will stop when we find the contact, and it will return either the property if we have it, or it will return no such property if it doesn't. Okay, Let me know if it was clear for you or you want me to go over it again. Great. Generate random fractions with JavaScript. Okay. Random numbers are useful for creating random behavior. JavaScript has a math.random function that generates a random decimal number between 0 inclusive and not quite up to 1. So almost 1, 0.999, and I'm not sure how many nines. Math.random can return 0 but never return 1, never quite return 1. Okay, note, like storing values with the equal operator, our function calls will be resolved before the return executes. Okay, I guess this is related to the store exercise. Change random fraction to return a random number instead of returning 0. Okay, this is easy. Math.random. Let's see what's next. Generate random whole numbers with JavaScript. Alright. So keep in mind that math.random will give us a number from 0 till 1 and not inclusive 1. We can multiply that number by 20 and then use another function, math.floor, to round that number down to its nearest whole number. So this is the method to create a random whole number generator. We generate a number from 0 to 1, then we multiply it by a given number, in this case 20, so it will go up to 20, from 0 to 19, I guess. Yeah, this technique will give us a whole number between 0 and 19, but it will also have decimals, so it will be something like 18 times. Well, let me show you. If we call a random whole number, let's see what we get. Console.log. Okay, look at that. We have 7.87123. Let's call it a lot of times. You can see we get a bunch of random numbers, but they have decimals. But now if we do math.floor around this, it will just cut off the decimals. So now we have random numbers, random whole numbers. We can run this how many times we want. We'll get a number from 0 till 19. So basically this number minus 1. Okay, we're calling it a random. Good. Use this technique to generate a random number, a random whole number between 0 and 9. So we can just change this to 9. Let's see. Or yeah, it should be 10 because I wasn't sure if they want 9 inclusive or not. So if we do that by 10, it will get a number from 0 to 9. Okay, that makes sense. Generate whole numbers within a range. Alright, so this is a nice trick if you want to generate random numbers within a range. What you want to do is to have the range, the minimum and max values, and then you can use, look at this, we have this nice line of code. So we use math.random times maximum minus the minimum plus 1, and then we append minimum. What happens is that this will create the maximum range and this will create the minimum. Okay, let's see. Create a function called random range that takes a range my min and my max and returns a random number that's greater than or equal to my min, and it is less than or equal to my max inclusive. Okay, let's see. I guess we can just use this and change min to my min and max to my max. So we're cheating a little bit. Alright. Play around with that and you can see how it works. Use the parseInt function. ParseInt function parses a string and returns an integer. Here's an example. So we have a string 007 here, and if we're using parseInt, it will convert it to an integer 7. If the first character in the string cannot be converted into a number, then it will return NaN, which is not a number. Okay, use parseInt in the convert to integer function, so it converts the input string into an integer and returns it. So we just do the return parseInt of string, like that. A couple of more. Use parseInt function with a radix. Okay, this is fun. We can convert to binary. Okay, parses a string and returns an integer. It takes a second argument for the radix, which specifies the base of the number in a string. The radix can be an integer between 2 and 36. Okay, it will look like this. So we have the string as the first argument and the radix as the second. Here's an example. parseInt 11 and we give it a 2. The radix variable says that 11 is in a binary system or base 2. This example converts the string 11 to an integer 3 because this is 3 in binary. Okay. Use parseInt to convert to integer, so it converts a binary number to an integer and returns it. Oh well, these are pretty simple. parseInt, we give it a string and 2 because we want to convert from binary. Alright, use the conditional ternary operator. Okay, this one is a good one also. The conditional operator, also called the ternary operator, can be used as a one-line if-else expression. And this is the syntax. We have the condition, so think of it like the condition you put inside the if. If condition, then you have this. It will run this code. Otherwise, it will run this code. You can see that it's much nicer. It's a one-line if else. So here we have an example. If condition, return this, otherwise return this. Or we can just do return the condition question mark, the first, which is the if this is true, or if it's false, then it will return this. This is the case you'll use the most, the ternary conditions, when you want to return. So instead of saying if and then return, then else, then return, you just return the condition and ternary operator. Okay, use the conditional operator in the check equal function to check if two numbers are equal or not. Okay, so return A equals B. If it's equals, we want to return equals. O. Otherwise not equal. Again, we have the condition, then after the question mark we have the if it's true, it will run this code, otherwise it will run this, sort of. Alright. Hang in there a couple more, just use multiple condition, ternary operation. Alright. Yeah, so basically we can do an if, else if, and else statement as a couple of ternary. So if this is true, we'll run this. Otherwise, we have another ternary. If this is true, we'll run this, and otherwise we'll run this. So basically the same as if, else if, and else. Hope this makes sense. However, this should be used with care, as using multiple condition operators without proper indentation may make your code hard to read. For example, yeah, that's true. This is much harder to read, so you rather put it on 3 lines like this. Alright, let's see what we have to do here. Return. Check if a number is positive, negative, or 0. The function should return positive, negative, or 0. Alright, so let's think. If number is greater than 0, we want to say positive. Positive. Like that, and let's put it like here on the second line. Oh, sorry. Question mark. So if it's greater than 0, we say positive. Otherwise, we're going to do another check. Num less than 0. If it is, then we're going to say negative. And otherwise, we're going to say 0, like that. And let's also add a parenthesis here, so it will be nicer, although it's not required. Let's console.log this. Console.log to see if is it positive or not. Yes, it's positive. Let's put 0. It should say 0, and minus whatever, it should say negative, like that. So we nested ternary operators. Alright. Use recursion to create a countdown. Ooh boy. Okay, let's see. We learned about recursion, yeah. Now look at a more complex function. Okay. That returns an array of consecutive integers starting with 1 through the number passes to the function. As mentioned in the previous challenge, there will be a base case. The base case tells the recursive function when it no longer needs to call itself. It is a simple case where the return value is already known. There will also be a recursive call which executes the original function with different arguments. If the function is written correctly, eventually the base case will be reached. For example, say you want to write a recursive function that returns an array containing the number 1 through n. This function will need to accept an argument n representing the final number. Then it will need to call itself with progressively smaller numbers of values of n until it reaches 1. Okay, you could write the function as follows. We have the base condition, which returns an empty array, else we want count array to be countup n minus 1. Count array that pushes the n, and we return the count array. Okay. Interesting. Yeah. So we're keeping track of an array here. Okay. And we're pushing to the end the number. Alright, this looks interesting. At first, this seems counterintuitive since the value of n decreases, but the values in the final array are increasing. This happens because the push happens last, after the recursive call has returned. At the point where n is pushed into the array, count n minus 1 has already been evaluated and returned. Alright, we have defined a function called countdown with one parameter n. The function should use recursion to return an array containing the integers n through 1 based on the n parameter. If the function is called with a number less than 1, the function should return an empty array. So let's do that. If n less than 1, we want to return an empty array. For example, calling this function with n equals 5 should return the array 5, 4, 3, 2, 1. Your function must use recursion by calling itself and must not use loops of any kind. Alright. Okay. We can basically use this. And as they said here, this array is in increasing order because we are pushing before. push happens the last. But if we're pushing before, how can we do that? And look at that, we have constant. Haven't learned about it. Oh boy. Okay, so let's see, how can we do that? We push before we created with the value of n, and then we push what? We push the value of countdown with n minus 1. Let's see, is this right? Count array will be an array. Okay. Maybe change count up to count down and do n plus 1. Yeah, but that's not what they say, right? Oh. Yeah, but we have n and it will go bunkers, so no. We have to push before. Because we have n first, which should be pushed. Oh. Well, I have another idea. We can still use this, but instead of push, we can just do unshift. Count up. Oh, and we need count down. Look at that. So we're not pushing to the end, we're basically pushing to the front. So this fixes it. Alright, that's a little hack there. Use recursion to create a range of numbers. Alright. We have defined a function named range of numbers with two parameters, start number and end number. The function should return an array of integers which begins with a number represented by the start num parameter and ends with the number end num. Okay, the starting number will always be less than or equal to the ending number in your function. Your function must use recursion by calling itself and not use loops of any kind. It should also work for cases where both start num and end num are the same. Okay, I guess that if start num is equal to end num, this is our base condition, and we can return an array, an empty array. Else, we want to, let's see, we call the range of numbers with start num plus 1 and end num. Alright, we are incrementing the start num, but we also want to create an array var a result let's think how it was the previous one. So result was this. Yeah, won't work. Let's return the result also. But this will only get us the value. So what we want to do is put it inside the array. We can basically do this with spread operator, but we haven't learned about this before, so yep. Let's see. Console.log range of numbers 1 and 5. What we get? Empty array. Interesting. Numbers. Okay. Oh. Want an array to be start num. I'm thinking out loud now. So let's put the start number as the first, as the first argument, and then we are putting the range of numbers. So we can basically do like this: const, let's use var because we haven't learned about const before. The array will be start num, and then we're going to do array.push range of numbers, this, and we're going to return the array. Okay, pushing the array. Can't just think of a spread operator, but haven't learned about it before. How do we do it without the spread? That's the question. And we also want to go up to the end number. We can fake this by doing that. So this will work, but it's probably not what we want to do. Let's go to the previous one. Let's get this function and let's try to copy this. So we created the array, okay, with this, and then we pushed. All right, let's do the same. So we create the array with range of numbers, the call of the recursive, the call of the function, and then we push the start num plus 1. And then we return. Yeah, this will go the other way around. So we want to shift. And we want to only add unshift, sorry, the first number. Yeah. This check is a little off, but we want to go until the start number goes over the end number for some reason. Okay. This works. Let me know in the comments or in the chat if you have a better solution, because as of now I don't. And look at that, we're done. We completed the basic JavaScript section, which was pretty long. Look at that, 110 challenges. But yeah, it's finally done. Tomorrow I'm going to go over ES6 and probably also regular expressions. And let's see what's next. Debugging, data structures, algorithms. Okay. This will be fun. Oh well, I'm going to do this off stream. Thanks all for watching. I know that for some of you which know JavaScript already, it might have been a little boring, but for those of you who don't know JavaScript, I hope this was useful. Also, make sure that you also do this, so you code on your own to make the most out of it. Thanks all for watching, and I'll see you tomorrow. Bye.